Hello humans! Mr. Dodd back with a little bit more pre-calculus knowledge. I can solve one variable inequalities. So basically you're going to follow all the skills and rules developed from solving equations. For compound inequalities, there are multiple inequality symbols to deal with. So you have an and statement or an or statement. You just have more than one place to subtract or add or multiply or divide. If ever you multiply or divide by a negative, you need to flip your inequality signs. And then graph the solution onto a number line. Use open dots with less than or greater than. You use closed dots with less than or equal to or greater than or equal to. So if you want to give these problems a shot, go ahead and pause the video, give them a try, and then you can check your work after you're done. If not, I'm going to get going. So subtract 4 from both sides. 3x is less than 7. Divide both sides by 3. X is less than 7/3. Number line. Whenever I have a single point on a number line, I always ask my students to provide some sort of context. So if this is 7/3, which conveniently I'm making my own graph, it doesn't need to be a perfect value. I want them to show me that 0 is somewhere off to the left of 7/3. So I'm going to use an open dot because it's a less than, and my arrow goes to the left because it's a less than again. This is a divergent sequence, or this one is divergent. So I'm going to use, to go interval notation, because that's part of my instructions, I'm going to go negative infinity to positive 7/3. Both of those are in parentheses. We can never include infinity, remember. And then 7/3 is an open dot. This one is a compound inequality that's written as an and. So I'm going to subtract 5, just like you would regular algebra. So we're basically trying to isolate the thing in the middle. I have a 5 plus 2x. I need to subtract 5 from all 3 places. So negative 9 is less than 2x is less than or equal to 3. Divide by 2 in all 3 places. That would give me negative 9 halves is less than x is less than or equal to 3 halves. So this is my inequality notation solution. Number line. Because I have 2 numbers, I'm not going to worry about putting 0 on there. Negative 9 halves, positive 3 halves. I'm going to do an open dot above the 9 halves, a closed dot above the 3 halves. I'm less than 3 halves, and I'm greater than 9 halves, so it's going to be that section right squished in between those two. Because it's convergent, I don't need to use infinity. For my interval notation, I would do parenthesis, negative 9 halves, comma, 3 halves, bracket. Okay, so that is part B. And then part C, this one's just, I put an easy solving one on there so you could see an or, but x is less than 3. Or, subtract 2, x is greater than or equal to 6. So if it's written as an or, you have 2 equations essentially to solve. And then go from there. I draw my number line. I'm going to put a 3 on there. I'm going to put a 6 on there. Solid dot above the 6, off to the right because it's greater than. Open dot above the 3, go to the left because it is less than. As far as interval notation, these are divergent. So negative infinity, comma 3. Both in parentheses because of the open dot. And then bracket 6, comma, infinity, parenthesis. So that is how we would solve, graph, and write solutions in interval notation for one variable inequalities. Hopefully that's help. Hopefully you were able to grasp that concept as we went through. Thanks.